Jai Jayendra, Namaste, welcome to my channel. Today we are going to solve the 14th question of the problem solving series which is based on arrays. So let's begin. Maximum sum in the configuration. This question has been asked in Amazon, Facebook and multiple companies, and the difficulty level for this question is medium. So what does this mean? Max sum in the configuration I into array of I. So here in this example, we have four elements 8, 3 and 1, 2. We need to return the maximum sum in the configuration whose max, where we will calculate the max sum with the sum of the product of the index and the element of the index. So for example here 8, 3, 1, 2. So what we'll do is we need to multiply 8 into the index. The index of 8 is 0, 1, 2, 3. So 8, the index of 8 is 0. So 8 into 0 is 0. 8 into 0 plus 3 into 1 plus 1 into 2 plus 2 into 3. So what is the value here? 0 plus 3 plus 2, 5 plus 6, 11. So 11. So is this the maximum sum? We can rotate the elements of the array and we need to see what is the configuration in which we get the maximum sum. So we need to return that maximum sum. Maximum sum of I into array of I. I into array of I. So what would be the answer to this question? Now if I rotate this, then it would become 3, 1, 2, 8, right? 3 will become 0th index, 1 will become 1 index, 2 will become the second index, and 8 will become the 3 index. We have rotated this. So in this case, the sum would be 3 into 0 is 0 plus 1 plus 2 into 2 is 4. 4 plus 1, 5, and 8 into 3 is 24. 24 plus 5 is 29. Right? Again, if we rotate this, then it will become 1 to 8, 3. So 1 to 8, 3. Right? So for 1 to 8, 3, the sum would be 3 into 3, 9. 8 into 2, 16. 16 plus 9 is 25. 25 plus 2 into 1 is 27. 1 into 0 is 0. So it would be 27. And again, if we rotate it, then it would be totally reversed. Then it would be 2, 2, 8, 3, 1. Right? 2, 8, 3, 1. This would be the elements, and the sum would be something. But here we can easily see the sum would be maximum when the 8 is at the last index, because at the last index the index value is maximum. So the answer to this question is 29. Similarly for this question, what would be the maximum sum here? So 3 into 0 is 0, 2 into 1 is 2, 1 into 2 is 2. So for 3 to 1, the sum would be 4. Then if we rotate it again, if it becomes 2, 1, 3, then what would be the sum? So we can't rotate it in any other way. We can't rearrange it. We can just rotate it, right? So the adjacent elements would be the same. So 2, 1, 3, the sum would be 0 plus 1 into 2 is 2, 3 into 2 is 6, 6 plus 2, 8. And again, if it is reversed again, so it would become 1, 3, 2, right? So for 1, 3, 2, the sum would be 1 into 0 is 0, 3 into 1 is 3, plus 2 into 2 is 4. 4 plus 3 is 7. Right? 3 to 1, 2, 1, 3, and 1, 3, 2. So this is the sum where it is maximum. So we will be returning this. So in this way, we need to find the, so 3 to 1, 2, 1, 3, and if it is reversed again, then 1, 3, 2. Yeah, right. So this is the answer. So how do we return this? How do we find this? So the first solution is we can find the I into array I value for the first configuration, and then we can store it, and then we can rotate the array, and then again we can find it and check if it is greater than the previous maximum sum. If it is greater, we will replace it. We have done some such kind of questions. So for those kind of questions, one we are finding the maximum sum every time, and then we are rotating it. So if there are 4 elements, we are rotating it thrice. So the time complexity for the naive solution is order of n square, by which we are going to find the maximum sum for all the configuration and check which is maximum, right? Can we optimize this? I'm not going to code this naive solution because it is very simple. So let's discuss the optimized solution. Can we solve this question in order of n? What would be the approach? Any idea? What is the intuition? So we are rotating, we are finding the maximum sum for each configuration. Can we avoid that rotation and find it in one go? How can we do that? So you need to think about the solution. How are we deriving this? We are multiplying these values again and again. And for the second configuration, when this 8312, so when this 8312 gets changed to 3128, the sum becomes more, right? Here it was 11, here it has become 29. Can we use this previous calculation to derive the second calculation? Is it possible? How do we use it? What has happened? What has changed? So we need to find the difference. What has happened when we have rotated it? So you see one thing over here, that when we have changed this, earlier 8 into 0 was giving us 0, right? But now this 8 has come to the last. Then what was happening? This 8 into 0 was 0. Now 8 into the size of the index, right? N minus 1. That is 4 minus 1, 3. Direct 24 has increased. So suppose the sum was S here. The sum was S here. And now what has happened with the new? What would be the new sum? The new sums, the first value A of 0 into whatever is the size 23, that has increased directly. So in that case, 11 plus 8 into 3, 24 is 35, but our answer is 29. But then what else has happened? So 3 into 1 was happening, 3. But here in this case, 3 into 0 is happening. So it's getting reduced. This has increased, but the 3 part is getting reduced. So now earlier we used to add 3 to this sum, right? 8 into 0 was 0, plus 3 plus 1 into 2 and plus 2 into 3, right? But what is happening over this case? Here 3 into 0 plus 1 into 1 plus 2 into 2 plus 8 into 3. This has come here, but 3 into 0 is 0. 3 was more here, here 3 is becoming less. 1 into 1, here 1 into 2, 1 is also 1 less. 2 into 2, 2 into 3. So everything is less. So minus 3 plus 2 minus 1. This has happened. If we do this, this gives us the answer. That means 11 plus 24 minus 6. That is 35 minus 6 is 29. We have got the answer from the previous things. So can we do it again for the next configuration? How did we find it? Suppose the sum was the sum is S, okay, and the sum is S, and what we have done, this sums, the sum, we had a current sum, say current sum, we have got the value, that is what is the current sum over here? 8 plus 3 11, 11 plus 1 12 plus 2 14, right? The sum, current sum will always be fixed because the elements are not going to change, right? Current sum is 14, and what is the current value for this configuration 8312? We have got the current value is 11. Now what would be the next value when we have rotated it, right? We just found it. The next value is current value, this current value plus the A of 0. What is A of 0? We'll start from the first rotation. So first at A0, right? So we'll be doing first rotation, second rotation, we'll be doing the rotation till n minus 1, right? So n minus 1 from starting from 1, so A1 minus 1 is 0. So in this case, first rotation, 1 minus 1 into, what is the element over here? A of 0 into this 3 number of rotations, number of rotations that we are going to do. So the number of rotations that we are going to do is n minus 1. If there are n elements, we will be doing n minus 1 rotation. So current value plus this minus, what would be the minus value? We will be subtracting this 3 plus 2 plus 1. So 3 plus 2 plus 1 we are subtracting, we are not subtracting 8, right? Because 8 is already 0. So how can we get the rest of the elements? We can get the rest of 3 plus 2 plus 1 from, if we subtract current sum minus the first element. What is the first element here? Ai minus 1. So if we do this, if this formula is used for all the rotation and we find whatever the value that we have got, we find the maximum out of all the rotations values, we will get the answer. So that is the intuition. So let's code it. I think the approach, the intuition is clear. So let's code it. So what we are going to do, we have a value current sum equal to 0. Current value also we will have a equal to 0. And we have a int result. Right? Int result we have as int means. Okay. Now what we are doing for I equal to 0 to n minus 1, right? Starting from 0. So our current sum would be current sum plus array of I. So we have got our current sum. And now we have got our current sum and we can get our current value also. We could have got it over here itself, right? Current value is equal to plus equal to I into array of I, right? We have so 0 plus whatever the value we will be getting, and we have both the things here. Now what we will do, we will store it as result is equal to, say, current value. Okay, we have the current value right now. Now what we will do is, for I equal to 1 to n minus 1. So for the first rotation we have done, we have not rotated, first array we have done. Now we will be rotating it n minus 1 times, because there are n elements, and we will find the current, the configuration sum, and we will compare. How we will find the current the configuration sum? With this formula of ours. So what we are going to do, what will happen is, here we have the result, right? And we can have current value is this, result is equal to current value. We can have another variable, say next, right? So next would be uh, current current value, whatever we got the current value, minus uh, current sum minus a of I minus 1. We have got this, and then a of I minus 1 into n minus 1. So this will give us the next, whatever the next value is there, we have got it. And now our result would be max of result comma next every time, right? And then we can close this and we can return result, right? So in this way we can find the all configurations I into array of I sum, and we can use the previous sum to get the current sum. I hope the question is clear. The solution is also clear. The link to the question has been given in the description. Please try the solution with by your own and then come to my code walkthrough.
So here is the 14th questions code walkthrough section of maximum sum in the configuration. As already discussed, with this approach we can find the solution in order of n time complexity and with order of one space only. We are not using any hash map or any kind of such logic. So we are just finding the current sum and the current value, and we are using this previous current sum and current value to find what will happen if we rotate it, and the value of I into ai, how this will come for the next values, and whatever the maximum is there we will be returning it. While explanation, I forgot to write this part of the code, that once our next value we get the next value, then we must assign this next value to the current value, because for the again the next index value for this one we will be using this 27 to get our answer with this formula which we have derived. So the time complexity and space complexity is order of n and 1. We have solved it like this, and the explanation is already done. So let me compile and run it directly. So it's giving the right result. Let's submit it. So as you can see, all the test cases have been passed. So let me know in the comment section how was the explanation, and see you all in the next video. We will be solving the 15th question of the problem solving series. Thank you.